Yeah, so we are in a new era of intelligent automobiles. Like we are familiar with cruise control and automatic braking systems and things today. So tomorrow cars will be able to do more complex maneuvers, like just the lane changing and driving in like slow traffic. And it's kind of safe, reasonable to assume that by 2030 we'll be able to just relax and lay back in the car, read a good book while the car drives safely for us. However, this is made possible by software, a lot of software. And actually, this is a chart that's showing that already today, the cars are the things out there that are the largest number of lines of code. And it has, like a modern high-end car has more code than a Boeing or the Large Hadron Collider, or even than pure software projects like Windows Vista and Facebook. And we know that what comes with large software are bugs. And a bug in a car can literally kill you. And for a car maker, it can cost billions of dollars. So we try to address this issue, and to address this, we try to improve the design and validation process that's used to build cars. So this process, on a high level, looks like this. Like we start from some idea, then we have an engineer that's going to provide requirements, do some design, build, test, and iterate until we're happy with the result. So what's wrong with this process? Well, at the core of it, there is still a lot of tools that are used that are inadequate. Like Excel, I would argue, is still one of the most commonly used computer-aided design tool out there. So, but that's maybe not the main pain point. Like the main pain point is that at the core of, this process at the end, like reduced to some sort of error, trial and error process. And one trial is basically manual work and can run from a few seconds to a few hours, depending on if you're doing just a program or devising a driving scenario and simulate it. And if you want to get to some statistical confidence, ideally you would want to run like 100,000 trials, so you can see where the problem is there. So what we try to do, what our goal at Decyphir is to try to change this 100,000 manual trials to one manual step and 100,000 automatic trials. And so here is an example of our tool. So here is our tool playing a simulator, a driving simulator with a control algorithm that we want to evaluate. And one of the first thing that it does is that it generates test cases and is going to go through all those test cases for you and collecting data in the process. And then analyzing this data and provide some sort of results and telling you, okay, here, that went okay, that didn't went, and that this didn't go right. So, and more importantly, it will try to detect corner cases, that is situations where the thing were not okay. So, basically, the value proposition that we're trying to push there is, we think that can help car companies to go faster to market. And we had a case study with Toyota where we demonstrate some 70% reduction in manual verification steps. But it can also make challenging design possible with using some intelligence and finding those corner cases in design. And we had another case study where we had 80% reduction time in design time coming up with an original design that the engineer hadn't thought about before. And all this should result in higher assurance and like fewer recalls. So this was validated with in-depth collaborations with car makers and suppliers. Toyota and GM are actually paying customers. And we had a collaboration with them on advanced powertrain, emission control, so traditional things. And we also have a research project on verifying machine learning-based autonomous systems. And now we're kind of looking where we want to go next. So we see two opportunities. One is to continue working with some sort of traditional automotive design. There's a lot of software to develop and to verify there. And for this, we have a almost mature product. And the opportunity is to target users of Matter's suite that is becoming more and more ubiquitous. So there are thousands of users there. And the other track is the other opportunity is working with machine learning and AI-based autonomous driving. And it's an all solve. and very hot problem. And we claim that we're kind of at the state of the art of this in this direction, but it's still a very hard problem. There are challenges in both directions where we would need, the first direction, we need software licensing, development, marketing skills, so people to actually transform what we have into an actual product that we can sell. And the toll business is something that's still very competitive and tough. And for the verifying autonomous driving, AI-based autonomous driving, then it's still, more research is still needed before we get to a point where we can actually get money maybe. And the business model there is less clear. So we welcome, I mean, thanks for your attention, and we welcome like every suggestion or every feedback that on what you've heard.